Today we're going to find slope from two ordered pairs or 2 points. And so I've given a couple of examples that we're going to work through together. But before I do that, let me recap. Slope is the rise over the run, or the formula that we're going to use today is the y minus y and x minus x. Notice that we have the little sub 1 and sub 2. That indicates ordered pair 1 and ordered pair 2, and I'll explain how we're going to do that. You can also do it if I'm giving you the 2 points and they're on the graph, and we're going to talk about that as well. So if I were to give you two ordered pairs, again, I'm very visual, and so the first thing that I would do is I would decide which point I'm going to label as my first point and which point I'm going to label as my second point. So the way that I have my students do that is I have them pick one. So I might choose to pick this one first, and then I'm going to go through and I'm going to use my highlighter and I'm going to mark these are my x terms and these are my y terms. And now that's going to be important because when I write my equation, let me color code it for you so you can kind of see it. The slope formula is m is equal to y1 minus y2 over x1 minus x2. Now some teachers like to put the 2's first and the 1's separate. It really doesn't matter because you're the one who got to pick which one was first and which one was second. So as long as you follow the pattern, it's not going to be a problem. So in this particular case, since my x's are here, I know that all of my pink is going to go in the denominator and all of my green is going to go in the numerator. And that will help me keep organized so that I don't get my numbers in the wrong places on the formulas. So if I were to look at this, I'm going to do the two y's. Now I chose to do this one first. So that would be 5 minus 5, 5 from here, 5 from here. And then I'm going to do on this, since this one is first, this one is first. So on the denominator, I will then put 2 take away 0. And I will be left with 0 over 2. And so that reduces down to a plain 0. So let me try another one. Again, I'm going to get my highlighters out and I'm going to highlight the parts. So you can see I've highlighted them here. These are my two x's and these are my two y's because every ordered pair is written in the format x comma y. And so I'm going to use the formula now. The y's go on top. I have to pick one to start with. So this time I'm going to pick the first one just to show you that it doesn't matter which one I pick. I'm going to come over here and I will start with this 3 and then I will take away a negative 3. And since this 3 went first, this negative 1 goes first in the denominator. And I'm going to take away negative 4. Now it's just whether or not I'm good at my integers work or not. So if I were to do this as an integer problem, this would end up being 3 plus 3. And that would be negative 1 plus 4, which gives me 6 over 3, which reduces down to 2. And so my final answer would be this 2 right there. Now, if you are concerned about the fact that it doesn't end up being the same answer if you picked the other one, let me just show you what happens if I had gone and done this one first. So if I had picked the opposite way, it would have been negative 3 take away 3. And then it would have been negative 4 take away negative 1. And we would have had you owe me 3, you owe me 3 more, you owe me 6. And then this would have been keep, switch, switch. So I would have had a negative 3 on the bottom, and a negative would have made it a positive 2. So it won't matter which one you choose to do first. It is still going to get me an answer of 2. So let's try a couple more. So again, my first step on every problem is to go ahead and get my highlighter out and highlight the parts that I know are x's and highlight the parts that are y's so that I can keep track of them in the equation. And so we're going to do that together. Y's go on top. So I'm going to do 5 minus negative 2 because I chose this one to go first. And then 3 minus 5, and then I do the calculator work or the work in my head, and it does not reduce down. These fractions would reduce to a whole number. If you have one in this format, for now, I'm going to ask you to leave it in this format. So we have a rise of 7 and a run of 2. That way, it'll help us graph them a little bit later. But if you change that to -3.5 now, it'll be a little bit more challenging. So we're going to do another one. Again, the y's go on the top. So I've chosen this one, -3 minus 1, and then 4 minus -2. And so that becomes -4 over 6, which reduces down to 2/3. See how if it reduces, I go ahead and reduce it. Now I want to talk about a special case, and I want to explain why this one is special and this one is not. And so let me explain it. Let me finish highlighting right here. And so if you choose to put the y's on the top, so this is 2 minus 8 because I chose to do the first one first, and 4 minus 4. Look what happens when I go ahead and do the math work. Do you see how I have the 4 minus 4 and I end up with dividing by 0? This is impossible. You are not allowed to, and we learned that in grade school, you're not allowed to divide by 0. So this is what we call an undefined line. And it would essentially be a vertical line at +4, because if we had a table, it would be whatever number you want to think about, and then 1, 2, 3, every possible number. So if I were to graph it, it would look like at +4, we would have a dot at 2, we'd have a dot at 8, we'd have a dot. It would be a perfect vertical line. And so those are considered a special case. This one is not, and we did that on the first problem already. This one would be 7 minus 7 and then 5 minus -2, which would give me 0 over 7, which is 0. This, we don't consider it special, but we do have a specific way that we graph it. So if we were to plot the points, at +5, we're up at 7. And at -2, we're also up at 7. And so what you look like that is a flat line. So this is a horizontal line. It has a slope of 0. And this one is a vertical line, and it has a slope of undefined. And so this one is considered a special case because this is impossible to go up forever. Eventually gravity will catch you, so it doesn't continue. But this one, you can stay at rest forever. And so it can go forever in both directions. This is a fairly normal situation. Okay, so just a reminder, this is our formula. If you don't like it with all my colors on it, I'll show it again right here. But the change in the y's go on top. This is your rise number, and the change in the x's go in the denominator. And so again, we're going to use this formula every time we need to find the slope when we have ordered pairs, whether that be in ordered pair format or whether I give it to you in a table. So, thanks.